Differences between GARCH and GARCH models. GARCH models versus GARCH models. The autoregressive conditional heteroscedasticity, GARCH, is a statistical model used to analyze volatility in time series in order to forecast future volatility. Whereas, generalized autoregressive conditional heteroscedasticity, GARCH, is a statistical model used in analyzing time series data where the variance error is believed to be serially autocorrelated. GARCH models assume that the variance of the error term follows an autoregressive moving average process. GARCH models are developed by Robert F. Engel in 1980. GARCH-Q models are quite often difficult to estimate because they frequently yield negative estimates of BIS. Whereas GARCH models are developed by Boleslev in 1986 in order to resolve the problem of negative estimates. GARCH models are used to estimate risk by providing a model of volatility that more closely resembles real markets. GARCH modeling shows that periods of high volatility are followed by more high volatility and periods of low volatility are followed by more low volatility. Whereas, GARCH is a statistical model that can be used to analyze a number of different types of financial data, for instance, macroeconomic data. Financial institutions and markets usually use this model to estimate the volatility of returns for stocks, bonds, and market indices. GARCH is over-parameterized model, whereas GARCH is parsimonious model. Conditional variance of GARCH models is equal to functions of GARCH terms, whereas conditional variance of GARCH models is equal to functions of GARCH and GARCH terms. GARCH models does not capture leverage effects, whereas there are numerous extensions that can capture leverage and asymmetric effects of good and bad news in GARCH models. The error terms in an IRAC-1 model are normally distributed with a mean of 0 and a variance of sigma I square, heteroscedastic variance. Whereas, GARCH models are used when the variance of the error term is not constant. That is, the error term is heteroscedastic. Heteroscedasticity describes the irregular pattern of variation of an error term, or variable, in a statistical model. Example GARCH models are more similar to moving averages, MA specification, than an autoregression, AR. The example of GARCH model is given for idea and comparison, whereas GARCH models includes conditional variance terms as autoregression terms. The example of GARCH model is given for idea and comparison. GARCH models are non-linear models, whereas GARCH models are also non-linear models. Maximum likelihood is an appropriate technique used in estimating in both GARCH and GARCH models. The main difference between GARCH-Q and GARCH-1-1 is that the GARCH-Q model is the more likely to violate non-negativity constraints, whereas the GARCH-1-1 model will usually be sufficient to capture all of the dependence in the conditional variance. The GARCH-Q model can only allow for the previous Q lags of squared returns to affect the current conditional variance, and the value of Q required to capture all of the conditional dependence in the variance may be large, so that the GARCH-Q model is less parsimonious than the GARCH-1-1. Whereas, the GARCH-1-1 model uses only 3 parameters in the conditional variance equation, and is therefore highly parsimonious. The GARCH-1-1 model can be expressed as an infinite-order GARCH model, so that it can allow for an infinite number of previous lags of squared returns to affect the current conditional variance. Thus, the GARCH-1-1 model will usually be sufficient to capture all of the dependence in the conditional variance, implying that bin practice higher-order models such as GARCH-2-3 are not necessary. The appropriate approach to testing for GARCH effects, by running a regression, collect the residuals, regress the squared residuals on their lags and conduct a hypothesis test to check whether the coefficients of the lagged squared residuals are equal to 0. Whereas, the estimation of GARCH models is often performed by the method of quasi or pseudo-maximum likelihood, which proceeds by maximizing the Gaussian likelihood function even though the true innovation distribution may not be normal. In ARCH models, there are Q plus 1 parameter to estimate. If Q is large enough, accuracy of estimation is lost. ARCH models are especially useful when the goal of the study is to analyze and forecast volatility. Whereas, in GARCH models, mainly uses few parameters to capture long-lagged effects. Efficiency of estimation is improved. GARCH models are especially useful when the goal of the study is to analyze and forecast volatility. Kindly subscribe my YouTube channel Thesis Helper. Thanks for watching.